Hi everyone, let's talk about symmetry. Well, there's lots of different types of symmetry, but the two types that we're going to look at are reflection symmetry and rotation symmetry. Well, reflection symmetry is probably the type of symmetry that you think of when somebody says symmetry. I'm sure you've all done this before. You've probably folded a piece of paper in half to cut out a shape of a heart, and then when you open it up, the two sides, the left side and the right side, are symmetric. Well, that crease that you folded the paper down, that's called the line of symmetry because it divides the two halves into mirror images of one another. If you place a mirror on a line of symmetry, you will see half of the figure reflected in the mirror. The combination of the half figure and its reflection will have the same size and shape as the original figure. You can also use tracing paper to check for reflection symmetry. Trace the figure and the possible line of symmetry. Then reflect the tracing paper over the possible line of symmetry. If the reflecting tracing fits exactly, the figure has reflection symmetry. The following shapes have at least one line of symmetry. So, for example, in this flower here, we can see that there's one line of symmetry that's vertical, one line that's horizontal, another line that's diagonal this way, and then another line that's diagonal this way. So if we were to trace this flower, we could draw a line vertically and then flip the paper over so the pencil tracing side would be against the flower. It would line up exactly. Okay, the starfish also has several lines of symmetry. It has the vertical line, it has this diagonal line, it has this diagonal line, this diagonal line, and then this diagonal line. So there's 5 lines of symmetry in a starfish. Well, if we go on to a rectangle, it has 2 lines of symmetry, vertical and horizontal. Someone might think there'd be a diagonal line, but if we were to draw a diagonal line and like flip the tracing paper over or fold the shape up according to that diagonal line, these opposite corners wouldn't match up. So it only has those 2 lines of symmetry. Okay, if we go on to this picture, so it only has 1 line of symmetry, which is the horizontal, because if you look at the mountains, they're reflected down here in the lake, and the clouds are reflected down here and so forth, and so there's only the 1 line of symmetry. Okay, can you find the lines of symmetry in these shapes? Pause the video, take a few minutes, and see what you come up with. Welcome back. I love this picture of the zebra. It has 1 line of symmetry right down between its ears, down its face, and its, chest between its legs. So there's the 1 line of symmetry there that's vertical. The snowflake, there's a vertical line of symmetry, so there's 1. Down between these 2 points, that's 2. Down these 2 points, that's 3. Now if we go in between the points, there'd be a line of symmetry here, so that's 4. Here's 1, there's 5, and then here's 1 is 6. So there'd be 6 lines of symmetry. Now with the McDonald's sign, if you forget about the shading and the copyright logo thing, there'd be 1 line of symmetry right down between the golden arches. Okay, Batman, there'd be one line of symmetry. It's vertical right down the center there. Now this orange, if we assume each slice is the same size, then there'd be, one line of symmetry here, one line here, 3, 4, 5, 6, 7, 8, and 9. And then this flower, there's so many lines of symmetry, I'm not even going to count because we'll be here all night counting. So that was reflection symmetry. Now let's talk about rotation symmetry. The blades on the windmill do not have reflection symmetry. However, it can be turned less than a full turn around its center before it looks exactly the same as it does in its original position. So if we hold the windmill steady here in the center and we take this blade and rotate it around until it's here, then it's going to look exactly the same. Or if we rotate again, it'll be exactly the same here. Rotate again, it'll be exactly the same here. Rotate it one more time and it'll be back to its original position. So we can rotate it less than a full circle and have it look exactly like the original. To describe the rotation symmetry in a figure, you need to specify two things. The center of rotation, this is the fixed point about which you rotate the figure. And then also, one of two other things, the angle of rotation. This is the smallest angle through which you can turn the figure so that it looks the same as it does in the original position. Okay, so before, in this windmill, we could turn it 90 degrees and it would look the same, or another 90, or another 90, or another 90. So it would have 90-degree rotational symmetry. Well, to figure that out, you take 360 degrees and divide by n, where n is the number of rotations within one complete circle. And so if we start here, this would be 1 turn, 2 turns, 3 turns, 4 turns. So 360 degrees divided by 4 is 90 degrees. So that's how we came up with 90 degrees. The other way, instead of looking at the 90 degrees, what we could have said was it has rotational symmetry with 1/4 of a turn. And so if we go back to the windmill picture, we know if we turn it 1/4 of a turn, 1/4 of a turn, 1/4, and 1/4, that would make one whole turn. And so we could use the fraction 1/4 to describe the turn instead of 90 degrees. But they mean the same thing. 1/4 of a turn is the same thing as 90 degrees. Okay, so let's look at this other type of windmill. So if we take this and turn it once, twice, 3 times, 4 times, 5 times, 6 times, it comes back to where it started. And so it would have 60-degree rotational symmetry, or we could say 1/6 of a turn rotational symmetry. Okay, the recycling symbol. If we start here, we turn it once, it matches up, twice it matches up, 3 times it matches up. So 360 divided by 3 is 120 degrees. So it'd be 120-degree rotational symmetry, or we could simply say 1/3 of a turn rotational symmetry. Can you find the center and the angle of rotation or the fractional turn for these shapes? So let's take a couple minutes, pause the video, and see if you can figure out the angle of rotation or the fractional turn. Okay, welcome back. For this first shape, if we have this and a kind of leg looking thing. We could turn it once and it would match up here. So that's one turn. A second turn, it would match up here. A third turn, it would match up here. Fourth, fifth, and sixth, and we're back to its original spot. So it has 360 degrees divided by 6 is 60-degree rotational symmetry, or we could just simply say 1/6 of a turn rotational symmetry. Okay, this word symmetry. If we hold it here in the center and it'll turn around and it'll match up here, so that's one turn. And if we keep going, it'll match up when it gets back to here, and that's the original spot, so that's 2 turns. And so 360 divided by 2 is 180 degrees. So it has 180-degree rotational symmetry, or we could simply say that it has 1/2 a turn rotational symmetry. Okay, this one, the Google Chrome symbol. If we hold it here in the center and we ignore the colors, if we take this red and rotate it over here to where it's yellow, that would be 1 turn and it would match up, again, ignoring the colors. But then if we rotate it again, it'll match up when it gets to the green. So that's 2 turns, 1 more turn, and it would be back to its original spot. So this would be 360 divided by 3 is 120 degrees. So it has 120-degree rotational symmetry, or 1/3 of a turn rotational symmetry. And the same thing with this one. If you take this leg and rotate it over here, it'll match up. So that's 1 turn. Rotate it again, it'll match up here. So that's 2 turns. Rotate it again, and it'll match up here. So that's 3 turns. So that's 360 degrees divided by 3 is 120 degrees. So 120-degree rotational symmetry, or 1/3 of a turn rotational symmetry. Okay, this picture, if we hold it right here in the center and we ignore the colors, if we take this and rotate it over here, it'll match up. So there's 1. Rotate it over here, it'll match up again. So that's 2. So 360 divided by 2 is 180 degrees. And so we'll have 180-degree rotational symmetry, or 1/2 of a turn. And the same thing applies with the playing card. So if we hold it in the center, we'd have 1, 2, so that's 180-degree rotational symmetry, or 1/2 of a turn. Okay, so here are some links to YouTube videos in case you want to play around with symmetry and explore a little bit more.